Okay, welcome back, guys. This is Mr. Lundy, and today I got some of my igneous rock collection out for you, and I'm going to teach you how to identify an igneous rock based on its texture and its composition, and using your reference table, page 6. Just real quick, as an overview, igneous rocks form wherever you have hot magma or lava cooling and solidifying. So solidification means to turn into a solid. So you have magma or lava coming out of the Earth's crust, maybe where two tectonic plates split apart, maybe where a tectonic plate goes down under another one and melts, and some of it comes back up, forming a volcanic mountain chain, similar to like the Andes Mountains. The only difference between magma and lava is on the Earth's surface, magma is molten rock under the surface. So anyway, you can take any rock, igneous, metamorphic, or sedimentary, any pre-existing rock, and if it's melted and it solidifies, it is an igneous rock, no matter what it started out before. So igneous rocks can form when maybe some magma goes up and melts some pre-existing sedimentary rocks, or igneous rocks or metamorphic rocks, comes out of the volcano and it cools, and it's a different kind of igneous rock. Now, igneous rocks are categorized based on their composition and texture. There are ways to figure out both. So let's start with sort of what you see when you pick up an igneous rock. Well, when you pick up an igneous rock, you see different minerals. So the different minerals make up the composition of the rock. So rocks are, again, mixtures of minerals. So if you've got an igneous rock that's got mostly light-colored minerals in its composition, we say that that is a felsic rock. So felsic refers to its color based on the kinds of minerals that make up its composition. So on your reference table, down here on this side of the chart, notice color, lighter, composition, felsic. So down here, these are the minerals that are inside the different rocks. So again, if it's made up of like light-colored minerals, we're talking light whites, light grays, tans, pinks, things like that, then you're going to say that it is a felsic rock, and it is one of the ones on the left-hand side of the chart. On the other hand, if you pick up an igneous rock and you notice that it is made up primarily of dark minerals, black, green, brick red, dark gray, brown, we call it a mafic rock. And mafic refers to a composition of mostly dark-colored minerals, minerals that are rich in iron and magnesium, let's say, where the felsic ones are rich in silicon and aluminum. So anyway, so step one, there's different ways to go about it, but step one, you could just categorize them basically based on whether they're mafic or felsic. So all the light-colored ones, if they're 50-50, go with felsic. So this one here, it's got about 50% of each. I'm going to say that it's felsic. This one here, mostly light, felsic. Even this one here is felsic. On the other hand, these are your mafic rocks. Dark green, dark grays, dark browns, dark reds. Okay, now this one here is a particular favorite of students, and when you first look at it, you're going to say, oh, it's mostly dark, I'm going to call it mafic. But in reality, if you can look at this in a very thin section, if you chip off a very thin piece, you could actually see light through it. Now, this is actually a type of volcanic glass, and even though it looks dark, we're going to put it with the felsic rocks. This is the only one that is sort of counterintuitive. Okay, so now that we've divided them based on their color, which is their composition, okay, these are on this side, these are on this side. Next, we got to figure out whether they belong in this category called extrusive rocks along the top, or intrusive rocks along the bottom rows here. Now, what's the difference? extrusive, volcanic. They've came out of a volcano, or they've came up out of the earth on the exterior of the earth. Extrusive, exterior. And on the exterior of the earth, the temperatures are cooler than on the inside, so these rocks can cool relatively fast. And when they cool fast, their crystals inside don't have a lot of time to grow. Okay? So a lava comes out, it touches the air or water, it cools quick, and you're going to get small crystals that are hard to see, that are usually a millimeter or less in size, and it tells you that it cooled quick, and therefore you would then know it belongs up in this top exterior section. On the other hand, if you pick up a rock and you see large crystals, or if you see crystals, I like to tell students, that are bigger than the tip of a pen or pencil, if they are greater than 1 millimeter in diameter, we are going to say that it is intrusive. Now, intrusive rocks cool inside the earth, okay? So intrusive, inside. Now, inside the earth, temperatures are warmer, so the rocks remain insulated longer. Their crystals have more time to grow. And they have a coarse or a very coarse texture. They cool slowly. The ones that cool quick will either have a fine or a glassy texture. Now, one other texture to look for is what's called vesicular, or gas pockets inside the rock. So lava has dissolved gases inside of it. So when it comes out of the volcano, these dissolved gases want to escape into the atmosphere, and they blow holes into the rock as it's cooling, and you get a vesicular texture. So you might see that over here. So look for gas pockets, and that can tell you that you're definitely a volcanic rock. Okay, so that's about it. Hope this helped. See ya.